Greetings, Algebra 2 students. How are you guys doing today? Today we're going to continue our trek into probability. We're going to talk about two-way tables, which is an interesting way of organizing data, and it's pretty straightforward. I think you're going to like this. It's one of those things that it might take you a second to kind of see how it works and how it all lays out, but once you do, it's very doable. It's something you all can do. All right. So what is a two-way table? So a two-way table is a useful way to organize data that can be categorized by two variables. Now, there's one thing that's very important to kind of see and understand with the two-way table. Before we were doing probability, we were thinking about two distinct events happening. Maybe I flipped a coin, maybe I pulled a marble out of a bag. Those are two separate things that happened. But in a two-way table, we're only talking about one item that might have two different variables associated with it. So when we say and in talking about a two-way table, that's slightly different than when we said and when we dealt with our theoretical probability. Because when we said and before, we were talking about two separate things happening. And here we're talking about one item that may have two different qualities attached to it. And when we look at the first example, I think that will be a little bit more clear. So let's do that. Okay, number one says a satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend a TV provider to a friend. The results are shown in the two-way table. So if we look at the two-way table, we have two different variables. One variable is listed across the top, location, and you can see there are 3 different places people lived: Glendale, Santa Monica, and Long Beach. And we have their response, whether they would say yes or no to recommending this TV provider to a friend. All right, but what's clear is what we did last week. We were talking about 2 separate events. I drew a marble, I put the marble back, I did it again. That's 2 separate events. What we're talking about here is all people. All right, so everybody in this chart is a person, and they may or may not live one place, and they may have responded yes or no. Those are 2 different variables that are associated to a single person. Okay, a single person will have different variances or different responses to those 2 variables, but all the people in here are the same. They're all people. Does that kind of make sense? I hope so. Let's look at A. Well, what is the probability that a customer from this group lives in Santa Monica and will recommend the satellite provider to a friend? Express your answer as a percent rounded to the nearest tenth. So whenever I see a two-way table like this, I kind of take a minute before I jump into the actual problem to kind of look at the table itself and to figure out what's going on. So what I want to do is I want to figure out how many people total took this survey. And there's a couple ways to do it, but the way I always do it to kind of make sure that I'm doing it right is I find my totals. So we're going to do that we're going to start by looking at that yes response, and we're just going to add straight across. So we're going to take 294 plus 276 plus 320. If you don't have a calculator, go ahead, pause the recording, go grab one and come on back. But you can see if we add those numbers together, we should get 890. So 890 people total said yes to this survey. Does that make sense? Okay, well, how many people said no? All right, so we'll do the same thing. We'll add straight across that no row. So we'll do 52 plus 34 plus 44, and that's 130. So far, so good. I'm just basically finding my totals going straight across. Well, you also want to find your totals going down. How many people lived in Glendale? All right, well, I can find that easily by adding straight down. 294 plus 52, that's 346. How many people lived in Santa Monica? 276 plus 34 is 310. How many people lived in Long Beach? 320 plus 44 is 364. Okay, so all I've done is I've taken some time to just really quick find my totals for each row and each column. Now I kind of do that right at the beginning because I don't know what they're going to ask. And if I do that, if I take that like 2 seconds at the beginning to grab my calculator and type some stuff out, it's very possible that I've already answered a question that they have, and then I have to do no thinking. I just kind of find it and put the answer down. Does that make sense? Okay, so the last thing we have to do is figure out how many people total total took this survey. And there's two ways to do this. We could add straight across the bottom row, so 346 plus 310 plus 364. We could do that, and we would get 1,020. Or we could add straight down. So 890 plus 130 is also 120. So the key is, and I know I said it backwards in the way I had the animation going because I forgot how I did it. But the key is we should be able to add across or add down and get the same number. Okay, so 890 plus 130 is the same thing as 346 plus 310 plus 364. So why do I do it twice? I do it twice to make sure I didn't make a mistake. Okay, so if I added those two numbers across and down and they did not come out to the same number, I made a mistake somehow. So I had to go back and try to figure out where that was. Does that make sense? Okay, if you can always catch your mistake before you make it, that's always a great thing. All right, so now that we look at our two-way table and we've figured out what's all there, now we can jump into part A. Okay, so what is the probability that a customer from this group lives in Santa Monica and will recommend the satellite provider to a friend? All right, so let's remember what probability is. Oh, I'm sorry. There's two things we need to know here. They lived in Santa Monica. All right, so let's think about, in our two-way table, where are we going to be? We're going to be in the Santa Monica column, and they will recommend the satellite provider to a friend. So if they will recommend, how are they going to respond? They're going to respond yes. So we're looking for the intersection of yes and Santa Monica. And what number is that? If you said 276, then you are right. Okay, so we look at the question, we look what they're asking us for, we zero in on that part of the two-way table, and now we're ready to build our probability. Okay, so we want to express this as a percent rounded to the nearest tenth. Okay, so let's keep that in mind. Here we go. Probability is always the number of favorable outcomes over the total outcomes. So how many people lived in Santa Monica? 276. How many people in total did we survey? 1,020. So that probability, favorable outcomes over total outcomes, would be equal to 276 divided by 1,020. This is where you're going to need a calculator. I would just take that calculator and go 276 divided by 1,020 and leave it in a decimal form. They want us to express this as a percent. All right, so we're going to go from fraction to decimal to percent. Okay, so we got our fraction set up. You put that right in your calculator and you hit enter, and it should give you 0.2705 as a decimal. And now we got to convert this to a percent. Now remember, in terms of a percent, what you have to do is move this decimal place 2 units to the right. So as a percent, we're looking at 27.05. Everybody see how I did that? I moved my decimal place 2 units to the right. Now the question, they want us to go to the nearest tenth. All right, so what is the nearest tenth? That's only 1 decimal place. So what we have to do, if I can change my color here, is we have to go back to this number and look at the second decimal place. See how that second decimal place is 5? What does that mean? It means we have to round up. So our answer is going to be 27.1%. Done. Does that make sense? We went from the table to a fraction to a decimal, and then we moved the decimal place 2 places over to make it a percent, and then we rounded it. Okay? All right, let's look at part B. What is the probability that a customer from this group lives in Long Beach and will not recommend the satellite provider to a friend? Express your answer as a percent rounded to the nearest tenth. Okay, so again, let's find out where in the table are we. So there's 2 pieces we need from this problem. Where are they going to live? And what are they going to do? All right, so they live in Long Beach. So we're looking at the Long Beach column, and they will not recommend the satellite provider to a friend. So they're going to respond no to that survey. All right, so how many people fall in that category? 44. All right, so they said, look at 44. That's the intersection of No and Long Beach. Okay. So how are we going to express our answer? In terms of a percent rounded to the nearest tenth. So let's think about what is probability. It's the number of favorable outcomes over the number of total outcomes. Notice I'm saying this over and over and over again so that hopefully it sticks in your brain. Okay, how many favorable outcomes did we have? 44. How many total people were surveyed? That's still going to be 1,020. So there we go. There's our probability as a fraction. Okay, so if they said as a fraction, we would be almost done. We'd simplify if we could, and then we would call it a day. All right, but they want us to express this answer as a percent rounded to the nearest tenth. Okay, so here we go. We're going to take it in our calculator, 44 divided by 1,020. Think about what that decimal value is, 0.0431. Okay, so now we'll go ahead and move our decimal place 2 units to the right. 1, 2. So now we're looking at 4.31. 4.31. So they want us to go to the nearest tenth. So what do we have to do? We have to go to the second number after the decimal place and find out, are we going to round up or are we going to round down? So what number do we have here? We have a 1. So we're going to round down. So what is our answer? 4.3%. Done and done. Okay? Does that make sense? All right, let's try number 2. All right, number 2 says the classes at a dance academy include ballet and tap dancing. Enrollment in these classes is shown in the table. Yes means the student is enrolled in that class, and no means the student is not enrolled in that class. All right, so again, right off the bat, the first thing I'm going to do is I'm going to figure out how many total people I have there. All right, so let's start doing this. If I add straight down the yeses, 38 plus 86, that's 124. You can grab your calculator if you want to pause this part and do this part on your own, and then come back and see if you got it right. That'd be a great thing to do. If we look at no, we're going to do 52 plus 24. That should be 76. Let's add straight across. 38 plus 52 is 90. 86 plus 24 is 110. Okay, so now we got to find out how many total people they surveyed, so we can add straight across or down. Messed that up, my apologies. And that's 200. Okay, so what is the probability that a student is taking ballet and tap? All right, so ballet and tap. So if they're taking ballet and tap, that means they're going to respond yes to ballet and yes to tap. So we look at where we have yes and yes, and you can see the green box is now on 38. So 38 people have said yes to taking ballet and tap. Okay, express your fraction, your answer as a fraction in lowest reduced terms. Notice that word reduced, so we're going to have to simplify. Okay, what is probability? Number of favorable outcomes over total outcomes. So we're looking at 38 over 200. Okay, so now all we have to do is simplify that fraction because they want it as a fraction. Let's divide the top and the bottom by 2. 19 over 100. Done and done. Okay, let's look at part B. What is the probability that a student is taking ballet but not tap? Okay, so they're going to say yes to ballet and they're going to say no to tap. Okay, yes to ballet, no to tap. So let's look at our table. Look where it's yes to ballet and no to tap. What number do you think that is? Should have said 86. Okay, how are we going to express our answer? As a fraction reduced to lowest terms. All right, do you see how easy it is once you have the table? You just find that piece and you find your total and you go. It's the number of favorable outcomes over total outcomes. So a lot of this skill is just being able to read the table and knowing how to pull the information that you need out of it. Okay, so the number of favorable outcomes over the total outcomes. So it's going to be 86 divided by 200. Let's ask ourselves, can we reduce that? Can we simplify that? Yes, let's divide the top and the bottom by 2, and we'll get 43 over 100. Are we doing good? Done and done. Here we go. 2 is done. Let's on to number 3. If you want to take a pause on this and see if you can do this one on your own, that'd be a great thing to do. When you're ready, go ahead and hit play, and we'll walk through it. Okay, so a research group surveys parents and coaches of high school students about whether competitive sports are important in school. All right, the two-way table shows the results of the survey. So we have one variable is the role. Are they talking about parents? Are they talking about coaches? And one is their response. Do they think it's important? Yes or no? All right, so let's figure out our totals looking at this two-way table. So go ahead, grab your calculator. If you want to add the columns and the rows, figure out what the whole thing is. Hit pause now and do that, and then see if you're correct. If we add straight down, 880 plus 120 is 1,000. If I add straight down the coaches, 456 plus 45 is 501. If I add straight across the number of people that said yes, 880 plus 456 is 1,336. And the people that said no was 165. 120 plus 45. Okay, so now we can find the total number of people that took this survey by adding straight across the bottom totals or adding straight down the row totals. It should be the same number. 1,501, 1,501. So far, so good. Okay, part A. What does the number 120 from the table represent? All right, let's find the number 120 in the table. All right, there it is. What does that represent? That's the number of parents, it's in the parent column, who said no to competitive sports. So what would that be? That's the number of parents who think that competitive sports is not important. Okay, so the key in these problems is, can you look at a number and know what that number means? Half the times with statistics, it's not the answer that matters, it's do you understand what that number is representing? Do you understand what that statistic is saying? Okay, and that's what these questions are about. So 120 is the intersection of parent and no. So this represents the number of parents who think that competitive sports is not important. Okay, does that make sense? All right, let's look at part B. What does the number 456 from the table represent? Well, let's find that table 456. Find that table, oh my gosh, find that number 456 in the table. There we go. All right, so there it is. It looks like it's the intersection of yes and coach. So what does that mean? This represents the number of coaches who think that competitive sports is important. You see how I took that same phrasing and I just replaced like the variables? Once you start doing this, if you know what the question and the setting represents, it's super easy because I took a lot of this from the question. So the question says, this is a survey that says whether they think competitive sports is important. So I kind of stole that language and I just said parents, yes, coaches, no, or vice versa, or whatever you need to do to answer the question. Okay, and look at C. How many parents were included in this survey? That would be something that before we'd have to do some work on, but we don't. We've already done that. Look at the parent column. How many parents total took this survey? We already found that number. It's 1,000. So look, 1,000. Boom, we're done. How cool is that? All right, take 2 seconds at the beginning when you set these problems up, and it might save you some time going forward. Okay, are we good? All right, let's try number 4. So number 4 and 5, it kind of changes the game a little bit. Okay, so I got one more piece of notes, and I'm going to talk you through number 4 and give you a chance to try number 5 on your own. Okay, so the information from a Venn diagram can be displayed in a two-way table. So you may have remembered talking about Venn diagrams before, but they show the intersection of data. So if I look, here's at my Venn diagram, you can see I have 2 circles that represent 2 different things, and those circles are going to overlap and I can show how many people fall into both of those categories visually in a Venn diagram. It's the same information, okay? So let's look at it together, and I'm going to show you how to fill this out. So that is one skill you might need to do, is to look at a Venn diagram and be able to go from a Venn diagram to a two-way table. Because once it's in the two-way table, you saw it's pretty straightforward in finding your probability. Okay, so a Venn diagram shows the results of a survey in which 80 students were asked whether to play a musical instrument and whether they speak a foreign language. Use the Venn diagram to complete the two-way table, then answer each question. All right, so this is a good, I always love these questions when they give you a piece of information here. So it says that at the very beginning, how many people took this survey? 80 students. So when we get done, when we add all these numbers together, what should it equal? It should equal 80. All right, so that's a good thing to know going in. So if it doesn't, you realize you make a mistake and you can try to fix it. Okay, so when I look at a Venn diagram, I kind of look at the part where they intersect. That's the easiest part for me to start. So look here, where there's two circles overlap, there are 16 people there. That means these 16 people both speak a foreign language and play an instrument. So they are yes to both. Okay, so let's think about our two-way table. If we had to think about this as a yes or no question, how would we categorize this? Let me get my pen. Okay, we would say if they play a musical instrument, we would say they are a yes to an instrument. If they don't play a musical instrument, we'll say that that's a no to playing a musical instrument. If they speak a foreign language, we'd say that's yes to a foreign language. If they do not speak a foreign language, we would say no. So far, so good. Sometimes the yes, no can be helpful. Anywhere it says not, that means no. Okay, so 16 people said yes to both. So which column is yes to both? It's that top left box. Okay, so these 16 people are saying yes to both. Okay, let's look at the next section here. So I can look at this number on the outside to the left. This is in the circle of playing a musical instrument, but it's not in the circle of speaking a foreign language. That means these 25 people would say yes to playing an instrument and no to speaking a foreign language. Okay, so look at our table. Where is yes to an instrument and no to a foreign language? Left down, right there. Are we okay there? All right, now look at the blue circle. 30 people speak a foreign language. So they are in the box of speaking a foreign language. They would say yes to a foreign language, but they would say no to an instrument. These 30 people are not in the circle of playing a musical instrument. All right, so these 30 say yes to a foreign language and no to an instrument. So where in our two-way table would that be? Up at the top on the right. Yeah, so look at the row, yes for a foreign language, no to a musical instrument. It would be right there, top right. Okay, and the last one, we got the one last thing left over. So you could think of this to yourself and think, okay, how do I find that last number? I could add all this up and subtract it from 80. That's one way to do it. But look at the Venn diagram again. And if you look really close in the bottom left corner, you'll see that there's a number down there, 9, that's in this big black circle, but not in either of the orange or blue circles. What that means is that there are 9 people out there that are not included in either of those circles, so they would say no to both. That's the last number that we need. So there's 9 people that do not play a musical instrument and do not speak a foreign language. And the way we represent that is by putting that small number in the bottom left of our Venn diagram. Okay, so 9 people say no to playing an instrument and say no also to speaking a foreign language. Does that make sense? All right, that big skill there was just taking the Venn diagram and converting it to the two-way table. Okay, now that we have the two-way table, it's just like what we did before. All right. Okay, so there's our data that we just found. Now we can start answering our questions. If you would love to pause this and try it on your own, go for it. First thing I'm going to do is find my addition and my across of my rows and my columns. All right, so I'll do this kind of a little bit faster. If I add down my columns, 16 plus 25 is 41. So 41 people play an instrument. 30 plus 9 is 39. So 39 people do not play an instrument. If I add straight across, 16 plus 30 is 46. So 46 people speak a foreign language. 25 plus 9 is 34. So 34 people do not speak a foreign language. Okay, and then remember they told me how many people were there total? 80. So if I add these numbers together, I should get 80. And I do. Okay, so 41 plus 39 is 80. 46 plus 34 is also 80. All right, so now that we got all this data, we're ready to go ahead and start the question. All right, so what is the probability that a randomly selected student plays an instrument? Okay, express your answer as rounded to the nearest hundredth. Okay, now this one's a little bit tricky because usually they give us two things. They would say something about speaking a foreign language and playing an instrument, but they don't here. All they say is what is the probability that a randomly selected student plays an instrument, period. What that means when they only give you one variable, they want you to find the total of the people that fall in that category. So how many people total play an instrument? That means they could say yes or they could say no to speaking a foreign language. And we've already found that number. It's 41. All right, we added those numbers up already. Do you see how that 2 seconds at the beginning can make the answering a lot easier because there's less thinking when you actually go to the problem. And I'm always a fan of trying to take the thinking out if you can, because it can be challenging. It can be difficult. All right, how are we going to do this? We're going to express our answer as a decimal. Okay, so that's calculator, rounded to the nearest hundredth. Okay, that's a little bit different, but we can do it. All right, so here we go. Probability is the number of favorable outcomes over total outcomes. Okay, so how many people played an instrument? 41. How many people were there total? 80. So there's our probability as a fraction, 41 over 80. Okay, so what we're going to do is take that fraction, go to our calculator, convert it to a decimal. 0.5125. Okay, now what do they want? They want a decimal rounded to the nearest hundredth. That means they want only 2 decimal places, which means I'm going to look at this number here and think, do I go up or do I go down? The answer is I should go down. And the more I think about this, I might have done this next number here could be wrong. Nope, I did it right. Go me. We're going to round down, so it's going to be 0.51, done. Okay, I was confused. See how they gave you a number that ended in a 5? They're trying to trick you there. And I thought I fell for it myself because I couldn't remember what I did. All right, so hundredth means we look at the third decimal place. We want 2 decimal places in our final answer. Okay, does that make sense? All right, look at B. What is the probability that a randomly selected student speaks a foreign language and does not play an instrument? Okay, so we're going to say speaks a foreign language. So is that yes or no? That's going to be yes to foreign language. Does not play a musical instrument. That's going to be no to a musical instrument. Okay, so how many people fall in that category? 30. So once we have that number, we're ready to rock and roll. Probability is always going to be the number of favorable over the total. All right, so we're going to say 30 over 80. And again, they want this as a decimal rounded to the nearest hundredth. So we'll put that in our calculator. 30 divided by 80 is 0.375. We're going to round to the nearest hundredth. So we're going to look at that third decimal place and ask ourselves, should we go up or should we go down? And we should go up. So our answer here is going to be 0.38, 0.38. Done and done. Does that make sense? Are you guys good? Hope you are. We have one more question left. And I'm going to encourage you, if you have not already, to go ahead and hit pause on this recording. Try number 6 on your own. And if you can't do it, then hit play. And I'll walk you through it. Okay, number 5. The Venn diagram shows the results of a survey in which people were asked whether they own a cat or a dog. All right, use the Venn diagram to complete the two-way table, then answer each question. All right, so a lot of this, the setting up is the most time and the most difficult. Once you have it set up, the answers come really, really fast. Okay, so let's look at this together. So we have cat owner and we have dog owner. Start in the middle. 36 people are in the middle of both. Okay, so 36 people are both in dog owner and cat owner. Okay. All right, 57 people say yes to a dog and no to a cat. That's right here. 57 people say yes to a dog and no to a cat. 25 people are in the other boat. They say yes to a cat, but no to a dog. And then how many people own neither a dog nor a cat and say no to both? That would be 92. Okay, let's go ahead and find our totals. If I add straight down, 36 plus 57 is 93. 25 plus 92 is 117. If I add straight across, 36 plus 25 is 61. 57 plus 92 is 149. All right, the last thing we got to do is add the rows and columns. Total of 210 people took this survey. Okay, so question A, what does the number 92 represent in the Venn diagram? So there's our number 92. So look, that says no to a dog and no to a cat. So this is the number of people who own neither a dog nor a cat. Okay, these are the number of people who said no to a dog and no to a cat. If you have the same idea and you worded it slightly different than me, then you're good. Okay, these are the people that said no to having a dog and no to having a cat. Done. All right, B, how many people were surveyed? Well, look, we already did that. Look at our work. Where did we find that number? How many people total are in this survey? 210. Bam, done. Part C, what is the probability that a selected person owns both a dog and a cat? All right, both a dog and a cat. So they're going to say yes to both. Should be 36. So what's our probability? Probability is always favorable outcomes over total outcomes. So we're looking at 36 over 210. Now notice here they don't tell us how they want us to represent this. So if this was an open-ended question, then you have a choice. You could do it as a fraction, as a decimal, or as a percent. Any of that would be fine. Okay. If it's multiple choice, obviously the question choices will tell you which way they want it to be represented. So because they don't tell me, I'm just going to put it as a decimal because that's easy. I'm going to put 36 over 210 in my calculator, hit enter, and leave it. So 0.1714. They don't tell me to round, so I'm not going to. Okay, the SAT does questions like this sometimes where they give you a place to do like a free response, and you would put like the first like 3 or 4, I forget exactly how it's laid out in the SAT, 0.1714, and we're good. Are we okay there? All right, 2 more, and then we're done. Thank you guys for hanging in with me. All right, D, what is the probability that a randomly selected person owns a dog? All right, so they're going to say own a dog. Does it say anything here in D about a cat? No, it doesn't. So these people could say yes to a cat or no to a cat. So how many people own a dog, period? That's 93. So our probability is going to be the number of favorable outcomes over the total outcomes, which is going to equal 93 over 210. And that's going to equal 0.4429. All right, 0.4429. Done and done. Again, they don't say, so I'm just going to leave it as a decimal. All right, one more. We can do this. What is the probability that a randomly selected person owns a dog and not a cat? So they're going to say yes to a dog and no to a cat. So find that in the chart. Yes to a dog, no to a cat. 57. All right, so probability is the number of favorable outcomes over total outcomes, and that's going to equal 57 divided by 210. So they don't say how to do it, so I'm going to leave it as a decimal. Grab my calculator. 57 divided by 210 is 0.2714. Done and done. That's it. Does that make sense? Okay, I hope so. That's two-way tables. You can do it. You're pros now. If you have any questions at all, please don't hesitate to reach out to your teachers. We are here for you. I have been so impressed with all of my students, how you guys have been doing this. You guys are rock stars. Just keep doing what you're doing, and if you have any questions at all, let me know. Okay, until next time, hang in there.